In these next problems, we are looking at what happens to some basic functions that we know, like the quadratic function, when you add some other numbers to them. These are called transformations. So let's look at what happens when we transform these functions. We've got our basic function is f of x equals x squared. And you should know that looks like the basic U-shaped thing that touches down at the origin and goes up to the left and right. In fact, this one would actually be y, or f of x, equals x squared with nothing else added to it. Now we've got three others to choose from here, and our problem is to figure out what the minus 4 is doing. One way, if you're not sure, well, one way is to use a graphing program, plug it in and see what comes out. But you can also just go ahead and plug and crunch in some numbers. This one down here, let's see, it looks like we have the point 0, negative 4. If I put in a 0 for x, do I get negative 4? Well, yeah, if I put in 0 for there, I'd have f of x equals 0 minus 4. That would be negative 4. So that one seems to work. I might have to check another couple of points because we've got the point 0, negative 4 here as well. And you could go ahead and do that. But I'm going to give you some basic rules here about this quadratic function. First of all, the u is always going to point open upward if the x squared is positive. So these two here would have a negative x squared. This one right here would just be y equals negative x squared. What the minus 4 does after the x squared is just drag it down 4 units. So this is going to be our correct answer on that one. All right, let's take a look at this next one. We've got an absolute value function, and we have y equals negative absolute value of x minus 1. So what's going on with that? You know that the absolute value function y equals absolute value of x just looks like that with the point touching down at the origin. When you put a negative sign on, it's going to flip it over, just like it did with the quadratic. So instead of opening up, it's going to open down. So we can eliminate c and d here. And then the question is, what happens with this minus 1? And you might suspect that what happens is just what happened with the quadratic. It just moves it down 1. We can test that. We've got a point here that looks like the point 0, comma, negative 1. So if I put in a 0 for x, do I get negative 1? Well, absolute value of 0 is 0. Y would then equal negative 0 minus 1. Y would equal negative 1. Yes, that works. If I'm really paranoid about this, I could try this point and see if it actually works. That would be the point where x equals 1 and y equals negative 1. If I put a 1 in here, absolute value is 1. Negative 1 minus 1 would actually be negative 2. So this point doesn't seem to work. And our correct answer is this one. All right, let's look at just one more here. This is a cubic. And we've got f of x equals x cubed plus 3. At this point, you might see a pattern forming here. Our basic cubic function looks like this sideways elongated s, and it crosses the origin there. And you'll notice that some of these look just like that, like a. But this one, d, is actually flipped. It's flipped over. That's what happens when you get a minus x cubed. Okay? And then the thing we've got to figure out is, what does this plus 3 do? And you might suspect that since a minus 4 brought the quadratic down 4, a plus 3 would bring this whole shape up 3 points. And you'd be right. And it would then be, the correct answer would be A. And if you were doubtful about that, you could test it. Here's this point 0, comma 3. If I put in a 0 for x, do I get 3 for the function? Yes, I do. So that's a little bit of work with some transformations.